Joachim, what is so critical about critical machine type communication?
So critical machine type communication is about thinking of new use cases where reliability and delay is of paramount importance. An example is, for example, platooning of vehicles, autonomous driving, where communication between different vehicles has to happen with a high reliability and with very low latencies because there are control loops behind it. This happens also in other fields like remote control of machinery for operation in hazardous environment or in remote locations where there's a real-time control loop that is being run now over a network, or some industrial processes that are automated. So all of them rely very much on that you are certain that the messages get through in the delay bound. And that's why we call it critical machine type communication.
And what type of latency are we talking about, and how can we achieve that latency?
I mean, the latencies depend a little bit on the use case. In some of the extremes, and there are, some call it the tactile internet, it goes down to a reliability or to a latency requirement all the way to 1 millisecond that needs to be ensured end to end. And that, of course, is a big challenge of going all the way to these latencies, in particular if you want to guarantee that you can achieve these latencies. So it's the combination of the low latency with the high reliability in achieving it, which is the big challenge. And when we have wireless communication, there's always an uncertainty about the radio channel, the channel propagation, the signal variations. So one way to address the reliability is to exploit diversity. Diversity meaning that you can have it since we have low latency, there's not so much diversity gain in the time domain, but in the frequency domain or in the spatial domain. You can use a lot of diversity in order to increase the robustness and the reliability. And this can be from a single transmission point, a base station, but when we think network-wide, this diversity and robustness can also be done over multiple sites by having joint transmissions from different locations, having also the frequency dimension, having carrier aggregation across different sites for multi-connectivity, joint transmissions, coordinated multi-point transmissions, we can say. Yes.
You also mentioned that we need to have a toolbox in place to analyze this. Could you elaborate a bit more on this?
I mean, the diversity tools are which is multi-point transmission, multi-frequency transmission, fallback to other radio technologies. That's a toolbox already in this space. And then for the timing, it's also important to have a right radio frame structure, which allows us to do very quick decoding, which means we need frame structures which have short transmission time intervals, maybe less than 100 microseconds, and where we also have very fast channel estimation and decoding, so that we have at the very early part of the radio frame our reference symbols, which enable us to do channel estimation, to do the signal decoding on the fly as the data arrives.